Okay, good morning, everybody.
Good morning, Miss.
Yeah, answer your attendance. Afla, Ajmina,
Present, Miss.
Amaya,
Present, Miss.
Atulya, Atulya, Drishya,
Present, Miss.
Jyotish, Karthik,
Present Miss.
Karthik,
Present Miss.
Kavya,
Present, Miss.
Nachiketas, Neeraj,
Present Miss.
Rangeet, Vaishna, Vaishnav, Anjali, and Shruti.
Present, Miss.
Is the slides visible for you?
No, Miss.
Is the slides visible, Amaya?
No.
No Miss.
Wait. One second. Now,
Yes, Miss.
Yes, Miss.
Yes, Miss.
Rangeet, Vaishnav, Anjali.
Present, Miss.
Anjali, okay. Okay, let's have our class today. Last class, we were discussing about module 3, and you were dealing with the third layer of these used, and you have seen what are the different versions of IP addressing and what are the protocols that are necessary in order to obtain IP address as well as the physical address, right? Now, today we will be starting with the network layer. So, network layer, I have told you, one important function was called it as routing and forwarding. You should understand the important job of a layer is routing. Also, forwarding is present. Okay. So the
Miss, your
IP
voice is
protocol. Now, what do you mean by route?
Miss.
Voice is not clear. The one of Anjali, what is the problem?
ഒന്നും കേൾക്കുന്നില്ല. ഹലോ.
Is it audible for you? This is not. Can you comment it in the chat box? Can you hear now?
Yes, miss.
Am I audible now?
Yes, miss.
If there are the other important, now the other important function of the network layer is called routing. Okay. Now, what do you mean by routing? Routing means two jobs are included. Routing, it means two jobs are included in that. One is, the first job is that you should require some idea about the other routers. And you should also know where the other routers are located. I'm telling routing, it means two important jobs. One is you have to have an idea about the other routers around. Who are your nearby routers? And also where they are located. Okay, so the first job you can call it as routing. The first job you can call it as simply routing. Okay, now once the router knows the location of other routers, what it can do is it can send the packets to a given destination. Once it knows where all the routers are located, now what it can do is it can forward the packet or it can send the packets to a given destination. And that is nothing but the second job of the network layer. And you can call it as forward. So I have told you two terms here. One is the routing and the another one is the forwarding process. I repeat, routing simply means two jobs are included. One is routing itself and the other one is forwarding. Okay, now routing means you should have an idea about the other routers And also you should know where they are located. Okay, now the second job is once you identify where the other routers are, you should be able to send the packets to a given destination. And that process is called it as forward. Understanding, Jyotish, understanding what is routing
Yes,
and
miss.
what is forwarding. Yes, okay. Now, so I have told you if forwarding. So what is the actual definition of forwarding? Forwarding means it is relating to one's own neighboring routers, and you are sending the specified packet to its nearest neighbor router. You should be having the knowledge of all the routers. You should know the location of all the routers. Now the second thing is you have to route the packets to the corresponding destination. Okay, so whenever a router is encountering a packet, it must decide where to pass that packet. Maybe it might be connected to multiple routers. As an example, consider a router located in Mumbai. Suppose you have a main router in Mumbai. And the Mumbai router it has been connected to other four different routers. Other four different routers. One router is located in Ahmedabad, one in Kolkata, one in Pune, and one in Bangalore. So I have told you about an example to understand what is routing and forwarding. Assume the main router is located in Mumbai and it is being connected to other four different routers. One is located in Ahmedabad, one in Kolkata, one in Pune, and one in Bangalore. Now imagine you want to deliver a packet to Chennai. Your destination is in Chennai. So the Mumbai router, what it does is it must decide to pass it to the nearby router. I mean, which is a nearing router towards Chennai is the Bangalore router. You know, Chennai is nearer to Bangalore, right? So the Mumbai router, it must decide it to pass it to the Bangalore router, and that is nothing but that is nearer to the destination. Okay, now in order to do that, the Mumbai router, it has to do two important things. The first one is it should identify the different cities by finding out where they are located on the map. I'm telling the Mumbai router, if it wants to, it has to transfer it to the nearest router, that is the Bangalore router. And if it wants to do that, it should do two functions or two different things. One is it has to find out the cities where they are located in the map. So what it should have? It should have the map of India. Right? Now the second one is it has to forward the packet to the nearest router. Here the nearest router is nothing but Bangalore router. And if it is connected to Bangalore router only, it can reach the corresponding destination, which is nothing but Chennai. Okay, so what is the first job of Mumbai router is? It is finding out who is where. And you are generating a
വോയിസ് ബ്രേക്ക് ആവുന്നുണ്ട്.
some interruption. Yeah, that network some problem here. I have got it. Can you hear now? Yes or no? Okay. So what I was telling is, if I want to deliver the packet to Chennai, first I need to reach the nearest router. I told the Mumbai router is connected to the 4 main routers, one in Ahmedabad, one in Kolkata, one in Pune, and one in Bangalore. So in order to reach Chennai, where I have to connect, which is my nearest router? Bangalore router is the nearest one. So the first job is you have to find out who is where and you have to generate a map based on that. And that is called it as the routing table. Okay, now the second job is you have to send the packet to the nearest router. Sending the packet, that is nothing but forwarding. Okay, so routers need to find out where other routers are and how they are connected to each other. So routers, they should know where are the other routers located and also whether which is the nearest route to be forwarded. So they will learn about all these things by special algorithms, and that are called it as the routing algorithms. I have told you 2 things. One is the routing table and the other one is the routing algorithm. So routing table is nothing but they are generating the details where the other routers are. Where is the destination? How can I reach that? So all these things, they will be putting it in a table, and that you can call it as the routing table. Now, once it forms the routing table, the next process it has to send the packet. Right. Now, in order to send that packet, it has to find out which path I have to select. Identifying the places and putting it in the putting it in the table, that is called it as routing table. Now, if I want to deliver the packet, I have to find which route I have to take it, which is the minimum path, which is the least cost path to reach the destination. And that is done by means of some algorithm, and you can call it as the routing algorithm. Okay, so these are the 2 things that you are going to see it in this module. One is you are learning what are the different types of routing tables, what are the fields it contains, and you are also going to study the 2 important, slide I'll just show you, wait. So to the 2 important algorithms, one is the distance vector and the other one is the link state algorithm. So understanding what is the meaning of routing and what is the meaning of forwarding. So routing, as a summary, I can just tell that routing is making the decision which route to use or how the routing tables are created that helps in forwarding. Okay, now forwarding is what you have to do when a packet is arrived. So these are the 2 differences between routing and forwarding. Routing, identifying the route, the routing table is created, and once everything is bring ready, you have to forward the packet. Once the packet arrives, what you have to do it. And that is nothing but the forwarding process. Okay, so So network layer, I have told you 2 important things, that is forwarding and the other one is routing. Now, you are going in detail with forwarding process. Now, forwarding means to place the packet in its route to its destination. It requires a host or a router to have a routing table. Okay, so forwarding means you have to place the packet in its route to reach your destination. And it requires a host or a router to have a routing table. Okay, so a routing table is must if you want to forward the packet. Right, now when a host has a packet to send or when a router is receiving a packet to be forwarded, what it will do is it will look into its routing table to find the route towards the final destination. That is the process that is being happening when a packet is arriving, and once if you want to deliver the message from your source host to destination host, what are the things happening is when a host is having a packet to send, or when a router is receiving a packet which has to be forwarded, what it will do is it will look into its routing table, right? And it is based on the routing table, it will be routing into its final destination. But doing that process, it is impossible in today's internet network because lot of entries will be there in that routing table. So you want to reduce, so many contents will be there in the routing table. So what you have to do is you have to reduce the contents of the routing table. So the forwarding techniques can be of different methods. So in order to reduce the contents of the routing table, you are having different forwarding techniques. Okay, so the size of the routing table can be made manageable by different forwarding techniques. That is what you are seeing it in the slide. So the first forwarding technique method is called it as the next hop method. You can see it in the diagram, route method versus next hop method. But the main one, what you have to see is the next hop method. You are just comparing the two methods. Okay, now the second method, what you have is got the network specific method. And the third one is called the default method. So I told if you want to deliver a packet from the source, or if a router is receiving a packet to be forwarded, what it does is it will look into its routing table in order to find the route to reach its final destination. So you will have so many entries in the routing table. So some techniques are used in order to make the size of the routing table manageable. It should not get overcrowded. So you have got different techniques. In one technique is known as the next hop method. Now what is this next hop method? So you can see it in the slide. Look onto the right hand side of the diagram. So if you want to reduce the contents of the routing table, one method I told it is the next hop routing. Now look onto this routing table. You have the destination. If I'm considering the routing table for host A, you have two hosts, host A and host B, and you are connected through routers R1 and R2. Now, if I'm considering the next hop routing method, if I'm considering the routing table for host A, I want to reach, what is my destination? I want to reach host B. That is my destination. Now, what is my next hop address? From host A, I have to go through router R1 in order to reach my destination B. Right? So what it meaning is for each destination, you are finding the next hop. Okay, so routing table for R1, the host is B, the destination host is B, the next hop is R2. Now similarly, the routing table for R2, you have the destination as the host B. But you can see on the left hand side, that is called it as the route method. So route method means it is you will be having the complete information about the route, about the complete route. So if I want to deliver a packet from host A to host B, to which all path, through which all path I have to travel, that fully is displayed in the routing table. So you can see host B, look on to the left hand side of the slide, destination is host B, the route is R1, R2, then host B, right? For each host, I am finding the complete route. You are having the complete information, right? And if I'm considering destination host B, You can have route R2 and then the host B. Similarly, for other destination host B, you are having a route, the corresponding last destination, which is nothing but host B. So what is the difference between these two tables is, in the route method, you are, instead of having the address of the next hop, what you are having is, you are having the whole information about the complete route. Okay, so that is being simplified by the next hop method forwarding technique. So next hop forwarding technique means it is holding only the address of the next hop. It is holding only the address of the next hop. Rather than having the complete route information, it is having only the address of the next hop. That is the difference between the route method and the next hop method. Okay, so the content, when you can see the content is reduced in the next hop method. Understanding what is the one type of forwarding technique, that is the next hop method versus the route method. Understanding, yes or no? Kavya? Kavya?
Yes, miss.
Okay. Understanding the route method and the next hop method.
Yes.
Okay. In the next hop method, you are making only the address of the next hop. But in the route method, you are having the complete information of the full route. So that the routing table is more contents you will have in that routing table. Okay. So that is the first method, or you can, one way to reduce the contents of the routing table is by the next hop method. Okay. Now what is the next forwarding technique? So the next one is called it as the network specific method versus host specific method. So second type of forwarding technique in order to reduce the contents of the routing table is the network specific method. So network specific method, if I'm considering, it is simplifying the searching process. Now you can see it in the diagram. You have two networks, N1 and N2. The source S is being connected to the N1 network, and you have got four sources, four hosts connected to network R2. N2. A, B, C, and D. And these two networks, they are connected by a router R1. Okay, so what is the difference between this network specific and host specific is, now look onto the host specific table. So the source host is S, the destination host is A, B, C, D. So you are having all the details of the destination and you have the details of the next hop also in your host specific method. But come back to the network specific method. You have the destination N2 and you have the next hop router as R1. Now, what is the difference in notation of these two, that is network specific and the host specific? Okay, so what is the difference is, instead of having an entry for every host connected to the same physical network, you are having only one entry in order to define the address of the network. Right? So you know N2, you have several hosts connected to the same physical network. So instead of denoting all the hosts, what you are doing is you are making use of only one entry, and that is nothing but the address of the network itself. So you are assuming that all the hosts are connected to a single entity. The whole hosts are connected to the same network and you are considering it as one entity. The meaning is, if 1,000 hosts are connected to or attached to the same network, you require only one entry in that. One entry is needed in the routing table instead of 1,000 hosts. Understanding what is the difference between network specific and host specific. Host specific, you are writing all the hosts as the destination and you are finding what is the next hop. But since all the hosts are belonging to the same physical network, you don't require separate entry. You require only one entry in that routing table. Okay, so the meaning is you are treating all hosts connected to the same network as one entity. So what you are doing, you are simplifying the searching process, right? So that is the second forwarding technique, network specific method versus host specific method, right? Now the third method is called it as the default method. So default method means this method simplifies routing. So you can see it in the diagram. You are having a host A that is connected to a network with two routers, right? Now router R1 you have got, router R2 also you have got. Now router R1, what it does is it routes the packet to host connected to the network N2. You can see it in the diagram. You have the router R1 and you have the router R2. You have the host A. And it is connected to networks with two routers, R1 and R2. Now what the router R1 does is it routes the packets to hosts which are connected to network N2. Right. Now, for the rest of the internet, router R2 is used. So whatever network is being connected, that is connected through router R2. So instead of listing all the networks in the entire internet network, you can make use of only one entry there. And that is called it as the default way. Understanding? Rather than mentioning all the networks that is present in the internet, you are making use, you are assuming that all are connected, I mean all as a single entity, and a single router is flowing through, I mean it's passing the data to the rest of the internet. Okay, so you will identify what is the network address and you will be forwarding the packet based on that. So your destination is N2, your next home will be R1. Now, if any other, whatever will be the network, you are routing the packet through the router R2. Okay, so that is called it as the default method. Okay, so these are the three different forwarding techniques that is being used in order to simplify the contents of the routing table. Okay, understanding? So what I have told is, I have told the two main functions of the network layer. One is routing and the another one is forwarding. So routing means I told two important jobs are there. One is you have to have an idea about the nearby routers and you have to have an idea where they are located. And that simply you can call it as routing. So finding out who is where and you are generating a map. That process is called it as the routing table. Okay, so that is the first function. Now the second one, what I have told is forwarding process. So once if the router is knowing all the location of the other routers, what it has to do is it has to deliver the packet to a given destination. And that is nothing but the forwarding process. Okay, I have told an analogy also. You should identify which is my destination, which are my nearby routers, and which are the cities it is being connected. So once I identify all these things, I will be forwarding the packet. Okay, so forwarding process, and then I told you will have a table based on that called the routing table. Now, in order to forward the packet, I have to find out the least cost path. Which path I have to select? Many paths will be there to reach the destination. Out of that, which is the suitable path, which is the shortest path. And that is done by making use of some routing algorithms. And that we will be studying in this module itself after the next hour. I mean, tomorrow. Okay, so I told two important, routing table and routing algorithm. So routing table, it contains many entries. The ultimate aim is you have to deliver your packet to the destination, right? So how you are doing is you will have a table, each router will be having a table and they will look onto it. They will find out where exactly I have to go it. They will finding out the route and finally it reaches the destination. So a lot of entries will be there in the routing table. Now you can minimize it with the help of the three forwarding techniques. The first method, what I have told is the next hop method. Next hop method versus route method. Route method means you are the entire information of the complete route is mentioned in that table. So that means the routing table is little congested. So if you want to reduce the contents, you will be notating only the next hop, which is the nearby hop I have to go. So that is the first method, next hop method. Okay. Now the second one is the network specific method. Network specific method means rather than mentioning all the hosts that belongs to the same physical network, I will not write the host as the destination. I will be reaching the network. So that network address, I will be making it as my destination. So all the hosts which are connected to the same network, I am assuming it as a single entity. Okay, so if 1,000 hosts are connected to a same single network, what I'm doing is I'm making only one entry in that routing table instead of 1,000. Okay, so that is that second method, network specific method. Now the third method is called it as the default method. Default method means the rest of the internet. I don't want to specify what are the networks in an internet. I will be just making use of a default router and then they will pass through the rest of the internet. Okay, so instead of listing all the network in the entire internet, the host can just have only one entry. And that is nothing but the default. Understood this much, what I have told? Yes or no? Afla?
Yes.
Understood. Jyotish?
Yes, miss.
Rankit? Rankit is not there, right? Vaishna is absent. Okay, then Vaishna. So, I have Vaishna is there. See, so absent is Rankit and Rankit only. Okay, so just read your textbook today itself, then only you will be having an idea based on that. And also tomorrow I'll be handling 1 hour because Atulya madam has altered me 1 hour. So I'll be handling your second hour. Okay. And I have told you to call me. Only 2 people have called. What about the others? Nachiketas, why did you call?
Yes, miss. Normal.
What is the reason for not calling?